Hi guys, welcome back to Data Every Day. Today we have a data set of Marvel vs. DC movies. And basically it's just a list of 38 movies, 39 movies. And there's a label of whether it's Marvel or DC. And our features are rate, metascore, minutes, how long it is, the release year, the budget, how much money it made in the opening weekend, and how much money it made in the US, and there's one more for how much money it made worldwide. So let's get started. I'll just call this Marvel or DC prediction. And well, I already imported our libraries. We're just going to be using NumPy, Pandas, and from sklearn we'll be using the standard scaler, label encoder, and train test split function. And for our model, we'll just be using a simple logistic regression model since this is a very simple data set. So let's load in our data with pandas read CSV function. And we can get the file path right over here, paste it in. And it looks like we have a problem with the encoding. So we can just specify here encoding equals Latin 1. Alright, and we can see these two first columns aren't going to give us any useful information. So let's just go ahead and, actually before that, let's just check a little bit of preliminary information about it. We can see there are no non-null values, no null values, right, because there's 39 total, and there's not anyone that doesn't have 39. And it looks like the budget says it's an object, which is interesting. But I'm pretty sure this will just be cast to a float. Should be fine. I doubt there's any. I mean, we'll figure it out. But I think the only actual object column is original title and company. Right, these two. Everything else looks numerical to me. So let's go ahead and start pre-processing our data. So first thing I notice is these two columns are not helping us, right? We don't need to know the title in order to predict whether it's Marvel or DC, and we don't need this unnecessary index column. So let's just go ahead and drop those two. The first one we'll get from data.columns indexed at 0 since it's unnamed, and the next one is original title. Right, and we're dropping it from the column axis and in place. Okay, now our data is more manageable. This will be our label column. The rest will be our features. And you can see this is going to be a very simple data set to process. All we have to do is split off the Y, encode it, label encode it, and then scale the rest, and then feed it right into our model. So let's do that. First we'll split Y is going to be data sub company, it's called. And X is going to be everything except company. Oh, sorry, dot drop company. Not in place. Okay, so what we're going to do now is with X, which is just numerical data, we're going to scale it using the standard scaler. And then for Y, we're going to encode it into ones and zeros instead of Marvels and DCs. So let's scale X to start. Oh, well, first we'll make a scalar object, which is just going to be a standard scalar from sklearn. And then X will be scalar.fit transform X. Y, for Y we need an encoder, which will just be the label encoder from sklearn. And Y is just going to be encoder.fit transform Y. Now X, even though it's not a data frame anymore, well, we could look at it as a data frame just to get a vision of it. You can see we lost the column names, but we have all the the data in each column has been scaled so that each feature, each column, has unit variance and centered at 0. So most of the values will be lying between -1 and 1. And then we'll just split it into train and test using the train test split function from sklearn, and we'll give it a train size of 70%. What happened? Train size. Okay. Now we'll start training. And yeah, our model will just be a logistic regression, which we imported from sklearn. And we'll just model.fit xtrain ytrain. And we can print the score using model.score. xtest, ytest. Let's just make it format a little nicer. Model accuracy. And the reason we can use accuracy is because you can see the data is split pretty evenly between DC and Marvel. So we don't have to worry about skewed classes here. And there's very few training examples. So, you know, I'm not sure how much predictive power these features are going to have in predicting whether a movie is Marvel or DC, but I guess let's find out. And we have 91% accuracy. That's remarkable, right? How do we get such a high accuracy? There must really be some fundamental difference between Marvel and DC movies, even in terms of their ratings and their budgets. It's interesting, right? I'd like to know why that is. I wonder if maybe we should check the correlations. Let's do that. All right. Let's go back to data. So we have a little time here. Data looks like this. So I'm just going to, let's do it down here. Visualization. So data looks like this, and we're just going to label and code this column. So data sub company equals encoder, which we have before, dot fit transform data sub company. Alright, now data should be all numerical, and let's bring in this import Seaborn and matplotlib. Okay, and now we'll get the fig size. Let's make it a 12 by 10, and sns.heatmap. Well, first let's make our correlation matrix, which would be data.correlation.core, and then we're going to pass that correlation matrix into heatmap. Let's turn on annotations, and we'll specify the min and max. Alright, and I think that should be good. Plot.show. And wow, some very high correlations. But we're looking at a company, right? Interestingly, company is not so highly correlated with any one column. Right? Obviously it makes sense that these are highly correlated because they're all predicting how much money it made. But what's very interesting is that this company column, there's no one of them that's extremely highly correlated. It's the combination of all of them that contributes to whether or not we know it's a Marvel or DC movie. And I guess that's it for today. I'm amazed at the results we were able to get. 92% almost. So thank you so much for watching. If you enjoyed it, make sure to subscribe, hit the bell, and leave a comment in the section below. I'll see you guys tomorrow. Have a great day.